This is Unit 4 of Python programming, titled File Operations and Graphics. In this unit, we will learn how Python works with files to store and retrieve data. We will study different types of files such as text files, CSV files, and binary files. After file handling, we will be introduced to Python graphics using the matplotlib library. We will learn how to plot data using lines, markers, and axes, and also how to draw shapes like circles, polygons, and arrows. This unit is very useful for data storage, data visualization, and real-world engineering applications. File handling in Python is used to store data permanently in a file. Normally, when a program ends, all data stored in variables is lost. To avoid this, we use files to save data so that it can be used again later. Python allows us to create files, write data into them, and read data from them. File handling is very useful in applications such as saving student records, results, reports, and logs. In Python, files are mainly classified into three types: text files, CSV files, and binary files. Text files store data in a readable format and are easy to open using any text editor. CSV files store data in rows and columns and are commonly used for spreadsheets and databases. Binary files store data in binary form, which is not human-readable, but they are more efficient for large or complex data. Each file type is used based on the nature of data and application requirements. To work with a file in Python, we must first open the file using the open function. The open function takes two arguments, the file name and the mode. In this example, the file is opened in write mode, which creates the file if it does not exist. The write function is used to store data inside the file. After completing file operations, it is very important to close the file using the close function. Closing a file releases system resources and avoids data loss. Always remember, open the file, perform operations, and then close the file. Writing to a text file means storing data permanently in a file. To write data, we open the file in write mode using the letter W. If the file already exists, write mode will erase the old content and write new data. In this example, we write student details into a text file named student.txt. The \n is used to move to a new line in the file. After writing the data, we close the file to save the content properly. Writing to files is very useful for storing records, reports, and results. Reading from a text file means fetching data that was previously stored in the file. To read data, we open the file in read mode using the letter R. In this example, the read function reads the entire content of the file and stores it in a variable. The content is then printed on the screen. After reading the file, it is important to close the file to free system resources. Reading files is commonly used to display saved records, reports, and stored information. CSV files are used to store data in tabular form, that is, rows and columns. CSV stands for comma-separated values, and these files are commonly opened in Excel. Python provides a built-in CSV module to work with CSV files easily. In the first example, we open a CSV file in write mode and store student marks row by row. In the second example, we open the same file in read mode and display its contents. CSV file handling is very useful when working with large datasets such as student records, results, and reports. Binary file handling is used when data needs to be stored in binary form. Binary files are not readable like text files, but they are more efficient and secure. Python provides the pickle module to store and retrieve Python objects in binary format. In the first example, we store a list containing student details into a binary file. In the second example, we read the data back from the binary file and display it. Binary files are commonly used to store images, videos, and complex data structures. Matplotlib is a popular Python library used for data visualization. The pyplot module of Matplotlib provides functions to create graphs and plots easily. It is widely used in engineering, research, and data analysis to represent data visually. Before plotting any graph, we must import the matplotlib.pyplot module. In this example, we are only importing the library, which is the first step before creating any plot. In the next slides, we will see how to plot data using this library. A line plot is one of the most commonly used graphs in Python. It is used to show the relationship between two variables. In this example, the x-axis contains values from 1 to 4, and the y-axis contains corresponding values. The plot function is used to draw the line, and the show function displays the graph. Line plots are widely used to represent trends such as growth, variation, and changes over time. This type of graph is very useful in engineering and data analysis applications. Markers and line styles are used to make graphs more clear and visually attractive. Markers show the exact data points on the graph, while line styles change how the line appears. In this example, we use circular markers to highlight each data point and a dashed line to connect them. Using markers and styles helps in better understanding of data, especially when multiple graphs are plotted together. This is very useful while presenting results in reports and presentations. Axes, labels, and title are used to clearly explain a graph. The x-axis represents the independent variable, and the y-axis represents the dependent variable. Labels tell us what values are shown on each axis. The title describes the purpose of the graph in one line. In this example, we added labels for both axes and a title to the graph. Using labels and title makes the graph easy to understand, especially when it is used in reports or presentations. Sometimes we need to compare more than one dataset on the same graph. This can be done by plotting multiple lines on a single set of axes. In this example, we plot two different datasets using two plot functions. The legend function is used to identify each line clearly. Plotting multiple lines helps us compare trends and variations between datasets, which is very useful in engineering and data analysis. Apart from plotting graphs, matplotlib can also be used to draw geometric shapes. In this example, we draw a circle using the circle function. The first argument represents the center of the circle, and the second argument represents the radius. The add patch function adds the circle to the graph. The aspect set to equal ensures the circle is not distorted. Drawing shapes is useful in engineering drawings and visual representations. A polygon is a closed shape made up of multiple straight lines. In matplotlib, polygons are drawn using the polygon class. We define the polygon by giving the coordinates of its corner points. In this example, 4 points are provided, so a 4-sided polygon is created. The polygon is added to the axes using the add patch method. We also set the axis limits and aspect ratio so that the polygon is clearly visible and not distorted. Drawing polygons is useful in civil and mechanical engineering for representing plots, layouts, and sections. Arrows are used to represent direction, force, or movement in graphical form. In matplotlib, arrows are drawn using the arrow function. The first two values represent the starting point of the arrow, and the next two values represent the direction and length. The head width and head length define the size of the arrowhead. We also set the axis limits and aspect ratio so that the arrow is clearly visible. Drawing arrows is very useful in engineering applications such as showing force direction, flow direction, and vectors. File handling and graphics are very important in real-world applications. Using file handling, we can store student records, marks, attendance, and experimental data permanently. CSV files are widely used to exchange data with Excel and other software. Using graphics, Python can plot results in the form of line graphs and comparisons. This helps engineers and researchers understand trends and patterns clearly. Therefore, Unit 4 is very useful for practical applications in engineering and data analysis. Thank you for watching. Like and subscribe for more related videos.